As my house and workshop move reaches its inevitable conclusion in about 3 days' time, I thought I would assemble a quick compilation video to help people with machining problems. And in this video I will attempt to show you how to machine a spoked flywheel like this one. This flywheel is 3 3/4 inches in diameter, and I have a couple of these, so I'm going to show you how to machine one of them. Here it is. Here's the second of the flywheels, and as you can see it's a good bit bigger than the first one. That's because it needs machining down. Normally I would clean up these castings with a file, but they are actually so hard I don't think I'll bother. I also haven't bothered truing it up too much because it really is not worth it. I'm doing this just for the sake of the video. This casting is actually so bad I would normally have put it in the scrap bin. There's nothing wrong with the casting being hard. If the metal is hard, it's going to be hard wearing. Most cast iron is slightly too soft in my opinion, but beautiful to machine. The metal is alternately hard and soft on the same piece, so as the lathe tool cuts the metal, you will get alternate grey and shiny patches. Now this is not a big problem on the centre boss, but it's going to be a problem on the outside edge, and I haven't got to that bit yet. Common problems with castings are just being badly made generally, containing foreign pieces of metal in the mix, as well as chilling, and also sand blowholes. I'll discuss chilling first. A chilled casting is when the casting is cooled too quickly and the chilled part becomes rock hard, and I mean really hard. Almost impossible, in fact completely impossible to cut with a lathe tool, even a carbide tip lathe tool. It will just skate over the top of it when it comes to it. The only way out of it would be to surface grind it, and I don't have one of those, and neither do most other people. The parts often affected by being chilled are the thinner parts, for instance steam chest covers, which are quite thin and are very easily chilled. I've had a few of these, from good suppliers too, but you just send them back, they send you a replacement and everything's fine. It's not worth trying to machine it because you will not get it flat. The other major problem with castings are sand blowholes. So you start machining your beautiful casting and a little black spot appears, and the more you machine, the more the black spot gets bigger and bigger, and you see a network of holes in the casting full of sand. And the really annoying thing about it is you may already have machined some of the casting before the problem comes to light. Like this one for instance, the main boss is done okay, but I'm about to have problems on the outer edge. As you can see, this is a really bad casting. Look at the state of it. Look at the lumps on the spokes, and they are really hard. I did try with the needle file but got nowhere. Great for this demonstration though. If you watched the previous video in this series all about machining a casting, I gave a more detailed view as to what I'm doing. I'm not going to bother doing it twice. I nearly went into a coma on the last one. So now I've turned the flywheel round in the chuck, so it's now held by the newly machined part, and I'm attempting to machine the boss at the other side, which is equally hard. But I'll get through it. I'm taking very light cuts as you can see here because the flywheel is not held by much in the chuck, so it's going to take a while. These castings were originally bought off the auction site that we all know and love, and the seller stated casted off Stuart Turner castings, or something like that. Well, maybe they are, but I've never had a Stuart casting that machines like this. This is horrible. I'm using a carbide tip tool as you can see. If I was using a high-speed steel tool, I don't think I'd get anywhere with this casting. I would probably have to sharpen the high-speed steel tool before every pass. And if I put more pressure on this carbide tip tool, I'd probably break it. And what I'm doing in this one at the moment is facing the end of a piece of brass bar, just to clean it up and make it square. I'm making the support column for the turret. After I've faced off the end of the piece of bar, I used a centre drill to drill a small hole, then I drilled the hole much deeper with a tapping size drill for 2BA. A 5/16 by 32 thread is obviously 5/16 of an inch in diameter, but a 2BA just happens to be about 3/16 of an inch in diameter, so 2 imperial drill sizes less than 3/16 is the way to go. So one can say that a 5/32 of an inch drill is a good tapping size for a 2BA tap. And now for a bit of free-form turning. This is a very simple process. This lathe is very heavy duty, so it will take quite a lot of metal off. If you're using a smaller lathe, don't be quite as brutal as this. The main purpose of this column is to support the top part of the turret. It does need to be a little bit ornamental without being too fussy, and this part is critical. It needs to be exactly the same diameter as the width of the top part of the turret. Brass is a very soft metal and it's quite easy to dig in too deep. That's why my hand quickly flashed in front of the camera there to stop all the brass chippings from hitting the camera. This clip shows me parting off the piece, although it's all a little bit speeded up just to save time. One thing I didn't show on the video was the drilling of the hole in the other end of the standard, mainly because I forgot to press record on the camera. When I make these videos, I am actually doing the job for real, so that takes priority, and sometimes I just forget to press record. But I think you can figure out what I'm up to. The short piece of threaded bar sticking out of the top of the standard locates on the crossbar, and the hole in the base of the column is so you can use a bolt to mount the completed turret wherever you want to mount it. Once the turret components have been silver soldered together, the whole thing looks like this. As you can see, the component now has silver solder flux residue and some oxidization, but after having been dangled in my acid bath for a while, it now looks like this. And after polishing up the part and fitting the taps, it now looks like this. And here is a view of the turret with the 3 valves in place. The valves are fitted with shim washers, which allows me to get them in the correct position, and also some Loctite 542 to make doubly sure they'll never leak. These steam valves are slightly unusual. They have a 5/16 by 32 thread on the body of the valve, but the outlets use 3/8 by 32. This will allow for the use of 1/4-inch pipe to feed steam to the steam engine or steam pump, but as well as 1/4-inch pipe, I'm also including some adapters to allow 3/16 of an inch diameter pipe to be used for smaller engines. So that's just about it. I just have to make the plug for the end, then it's complete. That's it for now. Thanks for watching and I hope you found it useful. Please take the time to visit my Main Steam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.